So till now what we have covered, I think what we did was we did introduction to Java. That was first day we had done the introduction to Java and concepts of object-oriented programming, and that's what we had covered on first day. And second day, then we had looked at how do we compile, how do we write a Java application, creating a Java file, and in a Java file we could define class, interface, point. A very simple syntax was defining all four kinds of things and writing the main compiling, executing. Not only executing, we also looked at generating documentation for the classes. So there's a utility which comes with JDK, which is used for generating documentation for whatever classes, interfaces, anything which you define in Java. So just that look at the utility. If any of the covering those utilities later, and it will be more useful when we look at what is a package, how do we, what are access specifiers. If we're looking at that, so at that time, that will be, and it can again relate the document generation of documentation. And yesterday we had just a practice session for uh, creating that application, doing the hands-on. So now let's dive into Java. Start looking into Java. So we start, that's all. Basically, programming is all about data types. Okay. And Java, object-oriented programming especially is all about data types. So let's start with that. Data types. Let's start looking at the data types. So today's thing is about data types. So we have data types. Let's see. So data types in Java are categorized into two types. Then we basically have two kinds of data types. We got the primitive data types and we have the reference data types. Uh, Primitive types are the ones which are almost the same thing, which we also find in the C language. Primitive types we may also call them as the built-in data types. Built-in types of the language. So similar to C language. Right? So which are the primitive data types? Let's see those. Let's see list them. So smallest one we start with the byte. Right? We have short, int, float, and these are the primitive data types. The list of primitive types. From reference types point of view, let's list them. What are the reference data types? What are possible reference types we can have? The reference types which we can have in Java are we have arrays. So we have any data type. So array of any type. Array types, all array types, they are reference types. So any kind of array. Then we have any kind of class definition which we have. So all the classes which are defined. We can define classes in Java. We can define interfaces in Java. Or we may define enums in Java. Or we might have been defining annotations. Right? Enums and annotations they were introduced from Java 5 onwards. Okay, that's from Java 5. Primitive types and the reference types. Okay, now a few things. Let's first look at all the primitive types. So in the primitive types, uh, and differences from C language, just a comparison. In C language, we have a prefix which we can use. We can say signed by, unsigned, signed, unsigned. Those prefixes are available. In Java, we don't have any such. And we don't have anything like saying, oh, I want a signed here, or I want an unsigned here, I want a signed by, I want an unsigned by. Signed, unsigned are not keywords in Java. We don't have any such thing as signed and unsigned. Okay. And, the way it has to be treated is like this. All these types, which are the wide, short, lean, long, float, and double, these are always signed values. These are equivalent of signed values only. We don't have to put a prefix saying for this is signed, for this is not. They're always signed. If it's a byte, it's a signed byte. Right? If it's a wide, short, lean, long, float, or whatever, it's always signed. If it's a char, it's always going to be an unsigned value. Right? Okay. Okay, looking at the, yeah, what are the sizes of each of those? What's the size for byte? How many bytes? Byte would be 12 byte. Okay, short would be 2 bytes. Int in Java is going to be 4 bytes. Long is going to be 8 bytes. Float, float is going to be 4 bytes. And double, in case of float and double, the interpretation of the bits is according to this follows. I equal to 754 is the standard. But it's IEEE 754, single precision and double precision floating point. And here the single precision and double precision floating point. Float and double. And these byte, short, int, long, and int and long, these are whole number and they follow two's complement. They are nothing but they are in two's complement. And they follow the two's complement. And how to find the value, what is the value, and given those set of bits. As far as char is concerned, it's a unsigned pure binary unsigned. And boolean, boolean what is it? Oh, what's the size for char? Size for char is 2 bytes. In case of C language, it's normally 1 byte. Why 2 bytes here? It follows Unicode character set. It's not just an ASCII character set. In C language, it's normally when you say char, it becomes an ASCII character set. Follows the ASCII or some extension of ASCII. Right? But here, yes, we have. We'll be looking at what that Unicode is, and we have to fill up that also. Fine. Okay. Uh, let's look at these further. Yeah. How do we write the literals? Literals means the constants. Literal value, we call them as literal values. How do we specify literal values for the primitive types? For each of these types. Let's have a look at the specification for literal values. Yeah. How do we write the literal value? So for numeric types, right, how do we specify literals? Okay. Just to test this, right? It's similar to the way we write in C language, but just a small test. Uh, I'll write a Boolean expression. So tell me which is true and which is false. We have this expression says 1, 2, double plus And another one says 1, 2, double, 0, which is true, which is false. This is false. And this one is false, and this one is true. Now, and when you write a numeric label, you start with a 0, it means you are specifying octal. And because you start with a 0, the compiler takes it as octal. It's not only about Java, it's also in C language. Even in C language, that's the same. So if someone writes 018, the compiler rejects that source code. Saying, oh, that's something wrong. I can't understand what you're doing. Because you put a 0 in the beginning. It's an octal. Octal means 0 to 7 only is allowed. You can't use a 8. So that code which contains this anywhere other than inside a comment, that's going to be highly it's invalid. I don't understand this code. For the compiler. Yeah, so if you start with a 0, the idea was to let you know that yes, if you start with a 0, it is wrong. If you start with 0x, that's hexa, right? 0x means 0x for hexadecimal. And this is what was in C also. So if you want to write a numeric number, you could write it. You could specify the value in the form of octal value, decimal value, hexadecimal value. Now what was done is from Java 7, that's from Java 7, we have one more option of specifying our value in binary. So you could use 0b. Start with a 0b and then you only specify zeros and ones. Okay, so if you wanted to write a numeric label as binary form, from Java 7 that has been available. So numeric label in binary has been added from Java 7. 0b. Start with a 0b and then you can give zeros and ones. So 1 0 1 1. It's a vector, like a constant, like you write 12, or like this is what constant, right? So instead of this, yeah, someone could have written, or instead of 12, I could have written it as 0b, 1 1 0 0. That's 12, right? 1 1 0. It's always it's a 0. 0 start because your token starts with a 0b. That means you are specifying a binary. You are specifying the binary. And the way you are writing the correct, so you have option of specifying your numeric constant in binary also. And you can write in binary by using the 0. Right? Okay. See the size of int. What's the size of int? 32-bit. So the value you can give is 2 to the power of 32 minus 1. That's the maximum value. Okay. That turns out to be some 10-digit number. It turns out to be some 10-digit number. Okay. Let's look at another way of writing constants. Something again, some enhancement which came from Java 7 for numeric labels. Okay. Okay. You have one in the beginning. You can put 32 bits and have one in the beginning. It's an int type. Suppose you are giving an int. One in the beginning. Okay. And after that, but put all 32 bits in. Okay. But after 0b only. It says 0b. So once your token starts with 0b, you're writing binary. I understand you are writing binary. You're not after 0b. You're not allowed in that particular token. You are not allowed to use anything other than 0 and 1. But there's something one more type of character. No, but yeah. Where you are telling me to add 1. 0b 1. After right? That, So most significant bit, but then give 31 more bits. Have 32 bits full. That is the most significant bit is what? You understand, sir? Negative value. Okay. Right. Now another point was, okay, especially for binary, first I did 32 bits and sequence zeros and ones. Related. Or let me give another example related even with decimal number system. Someone writes a numeric value and he says 1, 2, 3, 4, 5, 6, 7, 8, 9. That's his int value. That's some int value he wants. He wants to assign it to some variable. What's that value? How many thousands, how many millions or something? We can't put commas, right? Because commas are used as separated parameter passing. So we can't have commas here. But we still have a mechanism of grouping. What has been done in Java 7, this is again Java 7. From Java 7 onwards, what you could always do is you could decide maybe you want to use the American system. Maybe you can have 1, 3 underscore 4, 5, 6 underscore 7, 8, 9. And underscore for reader into will have it. See, someone writes 1, maybe a number of zeros, you won't be able to easily make out how many million or how many, and how if you're on an Indian system where how many lakhs or whatever it is, right? You can make it more readable. The same thing followed by so many zeros. How will it be made more readable? Okay. Here, maybe let's follow the Indian system. So we have 10 underscore 00 underscore 00 underscore 000. Underscores are allowed in the memory concept. Literals can have underscores from JavaScript, right? To improve readability, especially useful with binary, where you will be giving 32 bits. So group them into 4, have underscore after every 4 bits, right? Here, the use of underscore. But you can't have underscore at the beginning or at the end in the array. And you can't have two underscores together, right? So more readable. Yeah? And so that's what is from Java 7, okay? 0 this particular thing, and about the underscore. That's from Java 7. Okay. So something like right. We understand the limits, right? We understand the limits. Limits will be related to what's the limit of each of those data types? The range, the range of values what we can have. And for example, if I what's the range for int? It's a signed type, and therefore the range will be minus 2 to the power of 31 up to 2 to the power of 31 minus 1. Yeah, that's what the range. 32 bits are there now. One bit is the same. One bit is each one. Seven. And therefore you have. See how many total numbers are there? Zero. Right? Include it and put it on the other side. Less than zero. How many? 2 to the power of 31 are less than zero. And another 2 to the power of 31 is zero included and greater than zero. That comes to 2 by 3. 32 bits now. Right? So that int will be this. Right? Same way. short, long. Another thing was when I specify a constant, by default, I mean very little, if you are writing, the type would be considered as int. And numeric literals. If I write anything, 139, what's the type? Sometimes I might have a very large value. For example, let's say 1, 2, 4, 5, 6, 7, 8, 9, 0, maybe something like this. If I have some such number, it's not a valid. So if this token is coming to the compiler is going to say, I don't understand. And in order to say that this is a 64-bit value, don't use 32, don't use it as a use it as a long. Right? What we can do is we can always use a n at the end. It can be upper or lowercase. But it's always preferred to use the lowercase n. Okay? And it's always preferred to use the lowercase n because sorry uppercase n because the lowercase n is right, depending on the forms, sometimes it could be confused with the numeric literal one, right, the digit one, and L will look similar. Okay, and therefore it's always preferable to use the capital. Fine. Okay. So specifying literals for numeric type and the whole numbers. Right. For floating point types, and for floating point type, if I might put a value 12.7, what's the type? The default type will be double. And this will be considered as a type double. If I want to specify it as a float, you can have the suffix of upper or lowercase either way. Right? Have a suffix. Then the type will be considered as float. Right? Okay? Okay. So right. Specifying the constants, literal type, and specifying literal for the numeric types. Okay. And then coming to the char. Let's talk about the char type. Char in Java is it's a 16 or 2 bytes unsigned. If you are 16-bit unsigned. 16-bit unsigned is 16-bit. 256 is 2 to the power of 8. We have how many? 16 bits. 2 to the power of 16. Right? So what's the value? What's the range? The range, numeric range is from 0 to, if you are writing in decimal, 65505. 0 to 50, not 2 to the power of 16 minus 1. 2 to the power of 15, 16 minus 1. And here it is 16 because we don't have negative. It's not 2. And this is the range for char type. Char are nothing but numerical. What is a character set? We are talking about character set. Or see, I'll specify this in hexadecimal. So if I write in hexadecimal, it's 0 to and 5. This is the range for char data. Range for char data. And we'll be using, and here we'll be using hexadecimal. We'll follow some hexadecimal percent. Okay, how do we specify character constants? How do we specify character constants? Use single quote. Right? Character literals are specified single quote. Right? For example, single quote. What's the value? That's a single quote. What's the numeric value for this? The numeric value will be, what's the value for capital A? Decimal it is 65. Or in hexadecimal I'll say 41. In hex it is 0. That's the value for capital A. If it, this is upper case. Okay. For 0 to f f f. In hex. What's the range? Where does the lowercase appear? Okay, in hexadecimal. Hexadecimal is easier. Okay, fine. You can see, look at the ASCII characters. So initial ASCII characters. Let's look at ASCII characters in hexadecimal. And you'll find it's much simpler. So if I look at the ASCII character set, because okay, what's the character set used by Java? What's the character set used by Java? Yeah. Java follows the Unicode character set. Right? In Unicode character set, what is the range? What's the range for Unicode characters? What's the possible range for the Unicode characters? The numeric range. Okay, let's talk about ASCII. Let me put ASCII on one side. What's the range for ASCII? ASCII is a 7-bit code. We call it as ASCII is a 7-bit code. We normally the extensions for ASCII. So what's the range for ASCII? 0 to 7-bit code. So 0 to 7. That's the range for ASCII. Okay. And I'll use hexadecimal. Okay. What's the range for Unicode? 0 to in hexadecimal. The range for Unicode is 0 to 1. It's beyond the 16-bit range. It's not 16. Rather, it uses 21. It requires 21. That's a range for. Okay. What is unit? Okay. What is ASCII? Yeah, we can have a very quick look at what are ASCII characters. Well, the numeric coding, if you want to understand. ASCII is not simple. In hexadecimal, you have the range from 0 to 1f. This is nothing but what we call the control characters. And control A, control B, all these things. And they are going null. 0 is null, but numerical values. Then what is 20? Space. That's a space character. Hexadecimal. I'm using hexadecimal. 32. Right? Then we have 21 up to 2f. 21 to 2f. These are special characters. Punctuations and those kind of things at the rate. Special characters. Then we have 30 to 39. These are the digits. And digits 0 to 9. Next range 3a to 3 38 to 40 again. Some more special characters, less than, greater than, those kind of things. Right? Special characters. Then we have 412, 41. Yeah, 412, we go for how many? Plus 26. Or 1F. 1A. So this will be 5. 412. This is nothing but a capital letters. 5A is Z, capital Z. And capital A, capital. Then you have 5B to 6 0. Again, few more special characters. So special characters have been distributed in two places. And then we have 6 1 to 7 8, lowercase. Lowercase letters. And then what remains? 7B to 7B to 7E, not the 7F. 7B to 7E. These are again few more special characters. Okay, and 7F is a control character. And that's how the ASCII has been distributed. 5B260 special characters. Okay. So you have your special characters, right? Less than, greater than, if all those kind of things. Punctuations, comma, full stop, question mark. They are spread into these places, right? Okay. 21 to 2F, special characters. And then we have from 3A to 40, 5B to 60, 7B to 7. Those currency symbol dollar, such things. Yeah, Unicode. Coming to Unicode. But Unicode is extension of ASCII. Unicode is also an extension of ASCII. So in the Unicode, our initial 0 to 7F is same. Right? Initial 0 to 7F is same. What is Unicode? Unicode is a wide in language. Unicode covers is a character. Unicode is a character set which covers all the languages of the world. And it covers all the scripts. And we should say languages, it's about scripts because it's about writing. So it covers all the scripts of the world. The various scripts, whatever can be found, okay, including ancient scripts also. It could even include a lot of ancient scripts also. Yes. So, and it's a particular character set where you will find versions coming up one after another. So we've got a lot of versions of Unicode. The latest version of Unicode is 9. And as of date, the latest version of Unicode is Unicode 9. And initial version was in 1991. And initial Unicode 1.0 is 1991. At the time when Java project started, Java also started in 1991. 2095 birth date for Java. 95. That's the time when they could showcase the national. Okay. So uh, what we have here is Unicode has lot of, it covers lots of scripts here. It also covers all the Indian scripts. Okay. I'll just give you the ranges where the Indian scripts are here. And the range for Indian scripts starts, and not all of them, but a few of those. The Indian script starts from 0900. Each of those Indian scripts has been given a block of 128 characters. Okay. So 0900 hexadecimal, I'm writing hexadecimal to 097F. This is for Devanagari. And Devanagari is the script used in Hindi, Sanskrit, Marathi, and they would be following the Devanagari. Then we have 0980 up to 09FF. That's for Bengali. Then we have 0A00 to 0A7F. This is for Gurmukhi. For Punjabi language is Punjabi. The script is Gurmukhi. And then we have the 0A80 to 0AFF. And this is for so Gujarati script is here. And then we have the other Indian scripts. Telugu, Tamil, that's a place where we come. As far as Unicode is concerned, to understand about the Unicode characters, right? We have a site uh, code.org. That's a site where Unicode characters are. It's a site for the Unicode characters. Not many things happening on the site. Because Unicode is not about just a character. It's not just a character. Development things which you have done. It's a whole database. It's a whole database of properties about the characters. For this, which are all the punctuation characters, which are the digits, and which are the letters. Right? So many things. Okay, which are all the currency symbols? Yeah, India, for example, has two currency symbols. We already had a code point value of 20, what, 2088, and we have 20B9. This is currency symbols. Many currency symbols are in the range from 20A0 to 020 here. That's the range for this. You know, this was introduced in 5.1, version 5.1 of Unicode. Unicode has versions. You understand why versions for Unicode? Okay. New languages have been identified, new scripts have been identified, they have been added. You know, there was something very surprising, something you may not be even aware of. There are scripts which you are not aware of. There's a script called, and this was added in 5.1. The name of the script, and it's not like Gujarati. It's not like Gujarati. It's more like it will be closer to the Tamil. But the people are there in the Tamil area who speak a language which is closer to Gujarati. But the script which is being used is Sanskrit. The script which they follow, so they call it as a very selected area. So very few people using it for the same. But and that found a place in 5.1. So you know, people will submit and things
It's a
happen.
language that is not even Tamil and that's not even spoken in Saurashtra. That's something next to.
Yeah, it's in some part of Vellore and some other areas of Tamil Nadu. Some few selected areas in Tamil Nadu. This is something this got added in 5.1. I think in 5.1 only, we had a few, it was after 5.1, I'm not sure, 6.0 or somewhere. We had a few scripts more being added, okay, which are ancient things for us. The script which is known as the script from where all the Indian scripts have been derived, from which that's the root of all the Indian scripts. It's known as the Brahmi script. Even this was added in. It was after 5.1, it wasn't there in 5.1. Just immediately after that, Brahmi, and another one which is used in a lot of Jain scriptures. You'll find them in a script called. These are scripts, not language scripts. And these two were added later. They were added in the same version. Maybe 5.2 or 6.0, somewhere around that. So, fine, this just to give an idea that Unicode is something which needs not getting revised. But the way it has to be revised is no characters are ever replaced. You don't replace the new character. It's only addition which can happen, no deletions. Characters may get deprecated. Similar characters. Similar looking characters. I'll give an example of similar looking characters, but they are different. For example, okay, what is this?
What is it sex?
Huh?
Sex.
No, it's a Roman numeral 10. That has a different position altogether. It's not by group. Each character has a meaning. And that's, yes, is it a digit for that? It's a yes. The property is there. So they have a determinate properties of property. And where what this is. So what is Unicode gives an idea and something which is getting revised. And it's only because of revision that this could happen. And this one, Unicode is getting revised. And once this was declared, the next release of Unicode was held. And everyone knows this, right? This wasn't there earlier. Yeah. Okay. There's one more thing which I can explain about Unicode. But you see the difference something? I get the range for Unicode as one. What's the range for Unicode? Numeric range for Unicode. Okay, but this range. the size of char in Java? That's the condition. Now something about Unicode and the char. A char in Java is nothing but it is you can think of it as a UTF-16 encoding unit. It's a UTF-16 encoding unit, code unit, 16-bit encoding unit to encode Unicode characters. It is used for encoding the Unicode characters. A mechanism to encode Unicode characters in multiples of 16-bit values. You may use one unit or you may use two units to represent any Unicode character. You can try to understand what is the CPS system. How to have a look at what is CPS system. What exactly is UTF-16? How do we encode? Because the idea is we have numeric value in this range and we want to encode into UTF-16. Any value in this range, how is it getting encoded into UTF-16? Right? Even one more property about Unicode is Unicode is when I what is that range? 10 FFFF? Okay. If I look at that range carefully, Unicode is actually divided into uh, planes. They use the term as they have divided it into various planes. And the most of the characters, like most of the currently used languages and their characters, and whatever are in current, leave aside the ancient ones, but most of them, all of them are getting covered in the zeroth plane. See, the range is from 0 to 10 FL, which is divided into 17 planes. How many? 17 planes equal. How are those 17 planes? Now you can see this. It's nothing but you are having 0, 0, 0, 0, 0, 0, up to 0, 0. And that's your plane 0. When the first two next digits, consider them as plane number. And then what's the next one? 0, 1, 0, 0, 0, 0, 0, 1, no one. So you have planes from plane number from 0, 0 up to plane number up to 1, 0. So that is 70. 0, 0 to 0 F would have been 60. And you are including 0, 0. So 70 is how to figure it. The zeroth plane, the first plane which we have here, this is referred as BMP. In Unicode, it is known as BMP. BMP stands for Basic Multilingual Plane. And that's what they call it. And rest of it, all the other things, they are known as auxiliary characters. And we have the BMP and we have the all of it. Okay. If anything is in the BMP, 16 bit is sufficient. Then if your character is in BMP, now what has been done? Now just to support the UTF-16 encoding unit, okay, UTF-16 encoding system, what has been done in Unicode is we have a small range in our BMP. Within that BMP, there is a small range which has been reserved. Okay, we have the range from okay this you should be able to understand. Right? So we have a small range which is from D800 to DFF. This range has been reserved and not assigned to any character. in Unicode, this range has been reserved and not assigned to characters. This is reserved for what is known as surrogate pairs. And it is used for having surrogate pair. And it has two parts. So if I divide this into two parts, we have D800 to DPFN as the range for high surrogate, and we have DC00 to DFFF for low surrogate. Okay. So we understand. Now, this is a reserved area which is in the B, 16 bit. It's part of the system. Now, our idea is to encode any character in this range. We would like to be able to encode any character which appears in the range from 0 to 10. Now, how do we do this? So, any character in this range can be encoded into one 16-bit unit or two 16-bit single 16-bit unit or two 16-bit units. And when we say two 16-bit units, the two units will be a high surrogate followed by a low surrogate. It would be a high surrogate followed by a low surrogate. Let's understand how exactly those things come out and how that really has been derived. Okay. So if you look at that bits, right? If you got any value, so my target, the target is to encode values from 0 to 10 FF. Out of this, if it happens to be in the range from 0 to FF, okay, we would encode it as it is. What is the value? Right? We don't need more. We just need one unit of 16-bit. Right? Single 16-bit values. And if the value happens to be beyond this, now here when I'm putting this, yes, I understand it would be this range because that's not a valid count. It's not in that range. So if it happens to be outside this range, it's something from it's from 10. Sorry, it is sorry, 0 1. Right? After this it would be 0 1 0 0 0 0 up to 1 0 F F. That's the range which is remaining. If anything in this range, in that case, whatever is the value x, that x is the value which is in this range. From that x, reduce by x. What are we doing this by x? We are shifting one plane up. You have your value, shift it one plane up. If you shift it one plane up, it becomes a 20-bit number. Look at that range again. You'll realize this. I've shifted it one way down. One way down. Because I'm subtracting this, right? The zeroth plane has been just removed. Because I'm subtracting by this one. So whatever this becomes zero, right? So everything moves one plane down. If I subtract by this one, I'm shifting everything one plane down. So what's the last one? Zero, right? Zero, zero, zero. How many bits do I need for this? It becomes a 20-bit number. From x is my original value, which is to be encoded into UTF-16. And x is a number which is to be encoded into UTF-16. X happens to be the not in the PMP, the second location, right? Big number. Right? In that case, let's reduce it by this value. So it will become a 20-bit number, and it is definitely a 20-bit number. Right. So now I have those 20 bits, and I'll encode those 20 bits. Let's see how we encode those 20 bits. So our idea is to encode the 20 bits once the subtraction of subtracting by this value, we have some value x, right? So this value is nothing but I get a value which is in the range from 0, 0, 0, 0. I'm writing again hexadecimal up to x. That's my new range. This 20 bits, okay, is, let's say we have bits from bit number 19 up to bit number 0. This is what has to be encoded. So it is put into two 16-bit numbers like this. You have two 16-bit numbers where the first unit will have 110 1. First 6 bits are fixed. 110 Here it is 110 1. Your 20 bits from 0 to 9 they go here, bits from 10 to 19 they will go here. You got those 20 bits? This is my 10 bit, right? 10 bits here and 10 bits here. I have fixed 6 bits. Now, look at this carefully. What have you got? What we have got is, this is my first hexadecimal digit, that's a D. Then what is it? 10. And if it is all zeros, that's my lowest value which I can have. So all zeros, in that case, D 800. The first unit will be anything from D800. Then I can have all ones here. If it's all ones, this is D1011. What is it? 1011? B. F. F. That's my range for absolute.
How could we fix this 16?
That's how it is.
It's a fixed time.
Yes. How do you do UTF-16 encoding? This is how you do the UTF-16. Your number, which is to be encoded, is in the range from 0 to 10. And if you have to encode into UTF-16, that's the treatment you need to do. That's how you need to work on it. And that's how UTF-16 encoding is. So UTF, whenever you make a UTF-16 encoding of an auxiliary character, it would turn out to be the first unit would be a 16-bit unit, which is from the high cellophane. It is then followed by the unit from the low cellophane. If you look at this again, and now you understand this. This is D, 1, 1 and 0, 0 would be C, 0, 0 up to D, F, F, F. Now you can see how those surrogate math have been, the ranges have been decided. Those things are reserved and they will not be assigned to any character. First character will be assigned in that range. It's a reserved age of the. It helps with the UTF-16.
First 16 digits, those 6 digits are fixed or
Yes,
just
yes.
reserved.
And so it's a 16-bit number, 6 digits fixed, and 10 bits come from the other. And 6 bits
Got it.
and 10 bits from the other. 6 bits and 10 bits from the 20-bit number. So make it a 20-bit number and then put them here, and then you get your 216-bit numbers for UTF 16. Clear? Okay, so CAD type, yeah, not a big one. Yes. But one thing is about the CAD type itself. If you look at the CAD type, how do we specify the character constants? If we are looking at that, how do we write character constants? Oh, we have just one example, right? You can write this, that's fine. Then another way
Right.
in hexadecimal, we can do that, but in octal, you can use backslash. Oh, we had special characters, right? Backslash T, backslash R, backslash N, and those things. There are a few others, but what we find is exactly same list as well as backslash. Escape characters are there. So we have those escape characters here also. Okay, backslash, backslash, backslash code. And I have to specify what backslash. I can use backslash double quote, right? Backslash code, backslash double quote. Those characters are available. And so similar to C. Plus, another thing was, uh, yeah, now before I come to the other thing, because it's not only about Canada, it's not only related to the character functions. Now, what I am going to say is something which is applicable to your Java source code. When you write a Java file, Java source file, okay, when we write our program, what is a program? What is it made up of? Any Java program. What activities can appear in a Java? You can have comments. And then whatever tokens, the rest of all the tokens, whatever we can have, we are categorized as literals. We can have literals. We can have keywords. We can have separators. We can have operators. Okay, fine. And we can have identifiers. What is identifier? No. Fine. Identifiers are nothing but what are introduced by the program. And things used by the program in including system. Right? They are not coming from keywords. They are not coming from the language. Right? They are introduced by the programmer. So let's look at identifier rules. Yeah, rules for identifiers. Okay, what are the rules? Simple rules in C language. What are the rules for identifier? What can we use? Let's just see what can be used in identifier. Then we put few restrictions on it. We can have, we can use letters, letters. We can use digits. We can use the separator character, which is your underscore you're talking about. Okay, we can use the currency symbol like dollar, right? That's what we can use. Second rule, so that's the first thing. The second rule says we should be able to, we should not start with a digit. Okay, okay. Do not start. And third thing is very simple. It should not be a identifier. It shouldn't be identifier. Sorry, not that. It should not be a keyword of the language. It should not be a keyword. Right? Then it's a valid identifier. Identifier can't be a keyword.
But there are restrictions with the separators also. Like
Yeah, you don't have separator. Okay, when I say separator, it's just underscore. Separate is our underscore.
like hash and all that.
They're not separators. They're not categorized as separators.
Special kind.
They're special. So they're not part of anything in society.
Separator is just an underscore.
This separator underscore or some only a few other things which is qualified as separator. Okay. Fine. So yeah, what are the so which are the valid identifiers? If someone writes like this, A, B, C, 1, 2, 3, valid identifier. Okay, because it's made up of numbers and digits. If someone writes like this, valid identifier, yes or no? It's a valid identifier in Java because this is made up of letters only. If I start with something like this, but starting with a digit and that's not allowed. Here, the definition is the same. I can use a currency symbol. That's valid. Fine. Get this? Yeah. So when you write a Java source code, your Java source code is in Unity. Oh, the editor which you use may not be following code. Right? You might be having a plain ASCII editor. And even by using ASCII editor, you can still have these. You can still have any Unicode character being used. And what we have is something known as a Unicode escape. We have something called Unicode escape. So in a Java source code, we can use Unicode escape to specify any Unicode character using simply ASCII letters. And how? You should know the hexadecimal value of the character which you would like to use. For example, we have this letter, the Gujarati letter and the hexadecimal value for that is 0885. That's a hexadecimal value for the Gujarati letter right? So if I want to have a code which looks like this, right? That's a code which I would like to have. Can, okay, and then I would like to say equals encode, right? That's a code I want to write. But oh, I have to specify this purely in ASCII suppose because my editor is not supporting those things. In that case, okay, what you could do here is you would simply use. So if this is the equivalent of this can be. So this is equivalent of right can. Now a Unicode escape anywhere. That's why I was mentioning. It's not only about character. Any anywhere in your source code. Okay. Backslash u, lowercase u, followed by the four hexadecimal digits. That's the four hexadecimal digits. So we are saying 0885 equal to 4 backslash u 0885. Those two are same. It's also same as backslash u 0063 backslash u 0885 equal to 4 backslash u 0885 what's that? 0068. The lowercase letter c. You're free to use it, you can escape. The first thing, as soon as you give this file to a compiler, the first thing what the compiler has to do is it has to replace all the Unicode escape with the Unicode values. And then it starts the compilation. Identifying tokens, everything happens after interpreting, after using those Unicode escapes. It has to identify the Unicode escapes first. So anywhere in your source code, you are free to use the Unicode escape, and you will be able to specify any Unicode character. And in your source code, Java source code, you can write any Unicode character. Right? And this is when you write those backslash u and four hexadecimal, it's nothing but your UTF-16 encoding format. So, for example, if you have some auxiliary character to be used, it would be backslash u or high surrogate backslash u, the low surrogate. The two will be combined to create one Unicode character. Got the idea? Unicode escape. And that's the idea. I wanted to just like about this Unicode escape. Yeah. So and it's not that okay. It's only within code that I should be able to use backslash like Unicode escape. It's a Unicode escape. It's not a source code. So let's say okay, writing in hexadecimal Unicode escape, but applicable anywhere. Not only about codes, simple codes. Okay. See if someone writes a code which looks like this, tell me what it's like. Someone says get a equals code backslash u 000 a code semicolon. If someone writes a code like this, what's going to happen? And what is 000 a? It's for new line. It's for new line. Backslash r backslash n. It's backslash n. That's a backslash n. It's equivalent of the backslash n. So what's the compiler going to do about this? How the compiler? It's going to be a compilation error because when you write this, the compiler sees it as it becomes this for the compiler. That's how it sees. But there's a new line. It has to first replace the Unicode escape and then start the compilation. Understand? Anywhere a Unicode escape is there, yes, I have to replace the Unicode escape. The compiler is doing that and then starting the compilation. Identification of tokens is after the Unicode escape. Yeah. So the char type. Okay. Then we have the Boolean type. Right after the char, like this. Yeah. Yeah. Boolean is simple. Yeah. A typical thing about Boolean here, Boolean has only two possible values, and there are two literals for the Boolean type. What are the two literals for the Boolean type? True and false. And these are not keywords, these are considered as literals. They are not categorized as keywords. They are categorized as Boolean literals. But this third literal also, which has been argued, yeah, the third kind of a literal, which is yeah, the literal is null. And the four letters null, that's also a literal, but that's a literal for the reference data, not for the primitive. You can't say int a equals null or any of the primitive types cannot be assigned value. Null is for reference. Something which is assignable to any reference. True. And true false are literals, true false null. Okay, Boolean, just a difference from C language, a little difference from C language. Boolean here is a separate type and not a numeric type, unlike C language. And for example, I'll just show the difference. In case of C language, if I have a int a equals something, and what are the values of it? That doesn't matter. Someone can write a code which says if a, this is valid in C language. It's not valid for Java. And in C language, it's a numeric value. The zero and non-zero will decide whether it is true and false. Right? Whereas Java is strict. It says Boolean is a separate type. It's not a number. It's not a, don't give me a number. Where a Boolean is required, give me a Boolean only. You can't give a number and say, okay, you can understand by taking zero, non-zero. Boolean is a separate type. And not just, it's not a numeric type. It's a separate type of it. Right? In C language, Boolean is not a separate type as such. Right? It's just zero non zero. It's just a numeric type taking zero non zero. Whereas in Java, it's a separate type. Just two possible values, true or false. There's no boolean. Right? Clear, not boolean? Okay. So two little booleans. Okay. Before I can go to the left side, a few things about the floating point types. And that's about the floating point types. Floating point types are imprecise. What do you mean by they are not precise?
Can be extended.
Thank you.
Extended.
Extended. They are not precise. Okay. Say for example, I say float or let me use float. Float A equals 1.76 m. What is the value which will be stored in A? Do you think it is going to be 1.76%? No. Why?
After decimal, it takes an 8-digit position.
8 digit. How? That after decimal. How do you decide? That's not
So it
right.
has like something already defined in precision about two kind of values.
What's the precision?
Equivalent.
Is the precision same?
Can vary.
How? Very depending on. Yeah, it does like very depending on what. See, one thing, the problem is very clear. Right? We have long, right? We have the type long, which uses 64 bits. Long uses 64 bits. So we have how many distinct values? 2 to the power of 64 distinct values. It includes 0. Right? That there's so many distinct values. When we say float, float uses the mantissa and exponent form. Float uses mantissa exponent. Right? That's the exponent which is being used here. The weight is being used. Now, let's understand float or a double type. What exactly is there? The bits here. Basically, what we have is there's a most significant bit which is used as a sign bit, and then we have a few number of bits following it, which we call as the exponent bits. And this they use the term as it's a significant. This part is the significant. Rest of the bits are the significant. This is your sign. Before I go into that procedure, another interesting thing about float or floating points. Okay, what will be the result of this expression? I have float. Let me use float or double. So it could be either of those. Float A equals 75. 75 is, I mean, it is assignable to float, so that's not a problem. It's a bigger type. Float is a bigger type of calculation. Right? Then I have float B equals 0. Then I have got float C equals A divided. And then I say, let me print the value of C. What's going to be printed? What's going to be printed? And it's not about Java alone, even with C language.
Or it's an and. An and.
not an error unlike the whole. If you use int or long insert in and have a division which means denominator equal to 0, you can't have that. So we got a representation of special value. When we are talking about IEEE 754, you can search and have a look at, oh, what is this IEEE 754. And let's just see this. What is this IEEE?
Why it is wrong? Why it is
So in this, let me just repeat what what we have here is we got representation. So what will be if you have a positive value divided by 0, it's a positive infinity. If it's a negative number divided by 0, it's a negative infinity. And if it's a 0 divided by 0, then if it's a 0 divided by 0, huh?
it's a zero.
0 divided by 0. Mathematics. What is 0 divided by 0?
One.
Huh? It's not a 1, it's not a 0. 0 by 0 is not a number. Anyway, 0 divided by 0 is not a number. Okay? 0 by 0 is not a number. And our IEEE sample has in the standard is we have representation for we got the exponent, sign bit, exponent bit, and significant. Okay. Now all your exponent bits being ones is not going to be a finite value. You have all significant exponent bits at once. If this is all ones, then it is not representing a finite value. Okay. If this is all ones and all your significant bits are zeros, that represents infinities depending on the sign bit, 0 or 1. So that's a positive and negative infinity. Exponent is ones, significant one zeros, infinity. Sign bit is 0 or 1, so it's positive or negative. Okay, and then exponent bit all ones, but anything other than all zeros, any other combination if you take, they are all not a number. All not a number. That's going to be not a number. So yes, there are a lot of representations. That's not a number. Right? Any not a number. So lot of sentences are not a number. And of course, if this is not all ones, it's completely different. Finite. Then it's a flow. Yes. Finite flow. Otherwise, infinite or finite. All ones here means either it is infinity or not. Infinity, that should be all zeros. Fine? Okay. So now coming to that precision. Right, they should be okay. So special values. Right? These three are special values. Okay? Positive infinity, negative infinity, and not a number. These are special values for the floating point type and the double point. See, only difference between float and double would be about the number of bits. I think in case of float, we have 8 bits per exponent. In case of double, we have 10 bits per exponent. Okay, 8 bits and 10 bits per exponent. Rest of the bits are small. 1 bit per second. Okay, now coming to the precision. As far as the range of float is concerned, because we follow exponent format, the range of float is higher than the range of long. That has 64 bits. There is only 32 bits. But the range of float is higher because you are following the exponent format, raised to the power of so. And therefore, the value which you can represent. So if I look at a number line, okay, on a number like let's say 0 for float and double, the range is much higher. If that's a range for long, float will be much higher, much beyond that. Okay, that's what we understand now. Okay, another thing which you everyone will agree here is, let's say I consider between 0 and 1 and 0 and minus 1. Yeah, how many values are there between 0 and 1 for floating point time? How many real values, or how many real values or even rational values? I have got only 32 bits in case of a float and only 64 bits in case of a double. How many distinct values can I have? Can I represent all of them? And so we understand we can't have good precision. We can't. There's no way by which we can represent all the values on all floating point values. So it's nothing but there is definitely some distance between two representable floats. There's going to be some distance between them, between two representable floats. And this is what you can call as precision. This distance increases as you move away from zero. So near to zero, yes, the precision level is high. It's not just 8 digits, it could be much more. But when you are near to, as you go away from zero, it goes very bad. Right? To understand how bad it can be, I can assign. So I'll just give you a small example. If I try to assign float a equals, let me assign a numeric value 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose that's what I'm doing. The float a is not able to store this value exactly. It doesn't have representation between the two values. It doesn't. It has 1, 2, 3, 4, 5, 6, 7. Then it has 8, 4, and 1, 2, 3, 4, 5, 6, 7, 9. It can't represent any value between these two. That's not a storable in float. Yeah. And as you go away, the precision is going back. So one thing, never use float and double when you understand the range. Float is like please rule of float. Throw it away from the computer or Java. Any throw it away. Use double, that's okay. It's still okay. But don't use float at all. And it's advisable more to use float. Scientific applications or any such thing, don't use float at all. The precision is bad. So, but that's one advice. Never use float at all. They are imprecise. Understand, right? That yes, you should be aware. This is something which can be imprecise and its values are going to be higher. So in a banking application, financial banking and you have scientific. So other things are fine. Just doing some experimental code or something, and it's okay. But don't use that. That's some other ways of managing real high values. Yes, and go because even 64 bit is not good enough for me. Right? We're going for really very large numbers, right? So there are other types available, but that's not the primitive names. There are some classes which you can do. Okay, clear on this?
But why float is not giving error when I
It won't give error. It
A
will try to
divided by B?
store it at the nearest possible value. So when I put this, it actually 8 9, so it's closer to 9 to 5. If that's a value to have, it will change the value. Yeah, assigning the
When
nine
denominator
answers.
is b or 0, then also it never gives
When it's
value.
a denominator is 0, we understand what it will put. Right? Yeah,
Means
that's
that
represented.
is particularly defined for float only.
It's
That's
for
why,
double, float and double.
yeah, but not for int long. So
They
that
are
is
whole
the
numbers.
reason.
Right? When it is a whole number, its
Okay.
range is fixed.
So it will be that.
I don't have any. I can't represent that using byte short heap now.
Got it.
For float and double, we are following the IEEE 7.1. They have made a provision. Keep all exponent base ones and then you can represent your. So they got representation there. Okay. Yeah, have a look at. So I think primitives are okay. Right? And we will look at the reference type. Okay. So reference types are, so we can start with that. Arrays. There's something typical about reference type, how they differ. We can look at arrays and yeah, you know what are the arrays, the classes, interfaces, first yes we'll be trying to look at arrays, but even before arrays, just try to understand the difference between reference and other. Okay. What do we understand by the reference? Especially when we declare a variable of a primitive type and when we declare a variable of a relative type. Let's make the comparison. So primitive type is something like this. In A, I've declared a variable A. Like, I might assign a value or I may not assign a value. When I say in A, what exactly happens? There's a space allocated for the variable A. The size, that space could be 4 bytes. If I say long, for that would be 8 bytes. And we have the space to store the value. Suppose I give string. String is name of a class. So it's a reference. So say string S. Or even someone says S is equal, and he says let's keep the value. A string hello. That's a little. When we use like this, yeah, we have space for S, that's correct. So there'll be S. How much? Or if someone says, how much then?
That's the capacity of 16 and plus addition of whatever we are writing as a 16.
What is this number 16 coming?
4 plus something.
4 what?
Address.
Bytes or
No, it gives for the address something like that. Internal capacity.
what is done here is what is the space for S? S is always going to be the same size. S is not string. We say S is of type string. Basically, S is a reference type. In the word, it is simply a reference to some object. S itself is not an object, unlike the C++ language. In C++, if you declare a variable of a class, you have the object. That variable is the object. Here, no, it's not the object. Right? S is not the object. What we have here is we have an object which contains the string hello world. Okay, it's a string object and S is only a reference to that object.
This got confused because of the manual characters. Sorry.
Okay, S is nothing but a reference to a object. We have a variable of the reference type. It would mean it's only a reference which can refer to an object of this type only. Because S is declared as a string type, it will only be able to refer to a string object. It won't be able to refer to a different type of an object. Otherwise, all references are same. Only thing, this is a reference, but which is of a particular type, and therefore you are only allowed to refer to object of this. Right? Allowed to refer to object of a particular type only. All references are same. And arrays are also references. Arrays are also references. Let's see how. Right? Let's start with some array. Right? But this clear reference type references. So let's take an example of array now. Okay, how do we allocate an array here? So allocating an array is something like this. You have E. Now the way in C language, how do you do it? In A, then you specify something like this. This is not valid for Java. This syntax is not valid for Java. In case of Java, you have two different options. No, because this involves allocation also, right? In case of Java, you can separate it. You can say, now you have two options. Now, first option is like this. You can declare A, this one. This is only a declaration part which I am dealing with, not the allocation part. Okay. You can declare A to be a variable of type or even if you write something like this, both are same. These both are equivalent. They are considered equal. They are same. That's both are valid. Both are saying the same thing. A is a variable. It's a reference which can refer to an area of type. And the type is integer. See, the first declaration is much better. And in terms of that's my variable, that's my type. Type comes the variable. But just to keep some similarity with C, the second one is also allowed. Right? So arrays are a separate type. Array type. Yeah. Allocation. If I look at allocation, yes, we can do something like saying here itself either it would add here itself and you can say assignment equals. Now to allocate an array, we can use the keyword new. New is an operator. It's called as an operator new. The type of array I want, type of array is in. How many elements I want? Oh, I want an integer with 5 elements. Right? This is an expression which is an object. Okay, so when someone writes like this in array a equals new int 5, what's going to be done? What's going to be done? It's going to have a is here.
And
There is allocation of an array object which has got 5 elements, 5 integers, right? And a starts referring to this object. A starts referring to this object. Yeah, that's new int 5 is this one. That's the object with 5 integers in it. And this is your A. A refer to that object. Assignment here. When I make an assignment to a reference variable, refer to that object. Assignment is like change the reference to this. I have int a equals new 5. Later someone says a equals new int 7. What's going to happen? Oh, new int 7? That's a different object which has got 7 and 8. And you stop referring from here and start referring to this one. Stop that. Change this. A is my reference. A is my variable. I have started referring to a different object on type is integer array. So I can A is declared integer and therefore B can refer to any integer array. You can change that from the top. Whenever we allocate using new, the initial values for numeric types are going to be zeros. I allocate something, I get zeros. Right? If it was an array of Boolean, false value. Right? If it's an array of a reference type, okay. Right? Okay. Fine. So reference is okay. Can we continue to work? Can we continue to work? We'll have to continue. We'll come to the two-dimensional array. What is array of? We'll look at array of reference type, and then on the two-dimensional. Just a quick one more back here. You would have this possible, which is you could say a equals, and something like this. That's also valid. So array constants are also valid. Okay. One more point, which is related to any array of any type. You may have array of any type. If A is an array type, you can always use A dot length to know how many elements are there in the array referred by. A refers to some array. So A dot length will let me know how many elements are there in the array. Array here have fixed length. Any array in Java, array is an object. That object has fixed number of elements. Once it has been allocated, it is created with a fixed number of elements, which can't be changed. A variable may refer to a different object, whether it has a different name. A will be referring to a different object. So tomorrow we'll continue with this and we'll be looking at the array of reference type, array of then the two-dimensional arrays, multi-dimensional arrays, and we can have multiple dimensions. That will continue tomorrow. Okay.
सर इनका ये बैचिंग मॉर्निंग
नहीं है मॉर्निंग में
ओके
हाँ मॉर्निंग में हो रही है